Okay, here's my Zoia patch. I'm calling it Data Disruptor because it's not, well, I don't want to use the same name as Earthquaker Devices, the Data Corruptor, which is based on, and it's not exactly the same anyway. So, yeah, Data Disruptor. Oh, this is actually not the patch. There we go. Okay, so you have an audio in, and it goes into a fuzz effect, and the fuzz out goes into a oscillator pitch shift, and so audio in, fuzz, audio out, these two right here. And the reason that's connected there is because this is the audio mixer for the three different voices. Now on this one I connected the audio in to the voice 1 button because I was using another keyboard, just a kind of a toy keyboard, and I liked some of the sounds better directly from the audio in instead of through the fuzz. And so if you want, actually what I did with another version of this is I made an extra channel on the audio mixer to account for the fuzz effect. But if you want, you can, I'm not going to do it, but delete those and reconnect the fuzz to the audio. And so the audio out here goes, so that's going to the audio out. Here's your pitch shifting module, and then you have a keyboard. And the keyboard allows you to get your intervals. So the keyboard starts at A0 on the Zoia, and so the first setting is if you look up the you can look up the data corruptor manual from Earthquaker Devices, and you'll get a table like this, similar to this but not quite. But you can see here for the master oscillator, I've got the actual notes you should get from these intervals. And then on the sub oscillator, these are the notes you can get from those intervals. So the way it works out, so I use C as a base because it's nice and easy to figure out, at least to me. But on here, the A0 represents your unison pitch. Then you have an octave up, so it goes to A1. Then the third setting, you have a perfect fifth, and then the fourth setting, you have 2 octaves up. And then the fifth setting, you have 2 octaves plus a major third. And then the sixth setting, you have 2 octaves up plus a perfect fifth. And the seventh, you have 2 octaves up plus a minor seventh. And then you have, on the 8th, you have 3 octaves up. So what I did here is yeah, that fuzz out goes to your pitch detector. And you can see the audio out. And so this is really just over here, just so you can see what the notes are going to be from the fuzz before it goes into the pitch shift. So, but the fuzz effect is also connected to the pitch shift module, and the keyboard note out connects to the semitones to shift by. And then we have the pitch shift audio out, and you can see that that goes to the second voice of the audio mixer. Down here, this is another pitch detection module, and that way you can monitor the output, which is pretty handy. I tried a couple of different ways and finally figured out how to do it. So anyway, it was handy to have those pitch detector modules, so I'm leaving them in. And then you have a second keyboard. This is for the Sub Harmonic Intervals, and the first one, if you go back here, just show briefly, you have those type of intervals. So the first one, and on this one, what I ended up doing is I've got all the intervals 1 to 8 set up. There's your note out for that, and then here that's your pitch shift, and then I have a CV invert, and so there's the output inverted, and that UI button turns on and off the vibrato. So going back here to the intervals for the keyboard, you have an octave below, then you have an octave plus a perfect fifth below, and these are it's not the perfect fifth of the scale down below. It's so it's an octave plus then you go a tone, a full tone, a full tone, a semitone, and a full tone, and that's your perfect fifth below for instance for the second setting. Then you have 2 octaves below, and then you have 2 octaves and a major third below. Then you have 2 octaves and a perfect fifth, and you have 2 octaves and a minor seventh, 2 octaves or 3 octaves below, and then 3 octaves plus a major second. Now, so back to here, there's your CV invert. So all these values, they go through, the note out goes through the CV invert, so that you're actually taking away when it does the pitch shift. And that's, so you can see that the output is connected to the CV invert. And that's the audio out for that. And this is a pitch detector so that you can actually see the notes that result from that. And that allows you to, again, to monitor to make sure that you're getting the right intervals, because it can be tricky at times when you are working where your starting point is the note A when you're used to working with C. Now this one, so that's an LFO, that goes for the vibrato, and I connected it to a CV mixer, And I've got the levels here. And you can see that I've changed the level. Maybe that's yeah. See, it's down to 16% of the value, so that the vibrato only goes so far. You can change that to taste. Okay, this is a little add-on to the video. These buttons. So this is a CV invert. That's connected to the pitch shift. So that goes down. This UI button, as you can see, it turns this CV flip-flop on and off, the output on and off. And that is routed to it's routed to the CV multiplier. So that's one. This LFO is routed through a CV mixer, and the value of the LFO going in is reduced down to 16%. So that output goes into here, and then that goes to the pitch shifting of the master oscillator, as the Earthquaker Devices calls that, which is the second voice in the audio mixer. And that's the patch.